What if the most powerful AI tools on Earth were free, and the companies charging you for help were the ones falling behind? I'll show you why that move matters, what it tells us about who's really winning the AI race, and the old engineering rules that still beat fancy new tricks every time. Here's what went down. All through 2025, OpenAI and Anthropic hit the same ugly wall. They built wild tools, Claude Code, Codex, all of it. Shipped them fast. But those tools failed inside real companies. Not because the tech was broken, the teams using them just couldn't figure out how to put them to work. And that gap between what a tool can do and what a team can do with it turned out to be the whole story. Not the models, not the chips, the gap. Think about that for a second. Anthropic ships updates like every 8 hours. OpenAI moves crazy fast too. But the companies paying for these tools, they weren't seeing any of those speed gains. The dev teams just couldn't get it working for real. Teams that were meant to be changed by AI couldn't even get the basics going. And that's a bitter lesson, right? Your tech can be the best on Earth, but if no one can use it right, it doesn't matter. So what did OpenAI and Anthropic do? They turned to the big consulting firms? Publicly. They said, we built the engine, but we can't teach people to drive, so we're handing that off. Which, if you think about it, is kind of wild. The team's building the best AI on Earth, and their fix was to call in consultants, but then Jensen Huang walks onto a stage and takes the completely opposite approach. He launches NemoClaw and basically tells developers, you're smart enough. You can figure this out. Here's an open source framework. Go build. He looked at the same problem and came to a totally different conclusion. OpenAI and Anthropic saw a skills gap that only experts could close. Jensen looked at the same gap and saw something else, a tools gap. Give devs better tools, and they'll close it on their own. That's a totally different bet. One side says big firms need hand-holding. The other says devs just need the right building blocks. And the thing is, both of them might be right for different reasons. But what this means for how millions of people work with AI agents over the next few years are massive. So let's break down what NemoClaw actually is, because it's cleverer than it sounds. NemoClaw isn't a replacement for OpenClaw. It's basically a business-safe layer on top of it. It runs inside something called OpenShell. That's NVIDIA's own runtime environment, and that's how they lock it down for business use. The key pieces are these. First, you've got guardrails written in simple YAML files. They tell the agent what it can and can't do. Plain text, easy to read, easy to check. You can check them into version control and know precisely what your agent is allowed to do at any given time. Second, model rules that do two jobs. They check safety, and they make sure NVIDIA's own models get picked. Which brings us to the real play here. And third, the whole thing runs on local first setup. It runs on NVIDIA chips in your own building. No cloud, no third-party servers. Your data stays on your machines, under your control. Now here's where it gets really interesting. This is a strategic play, not just a product launch. Jensen is trying to move NVIDIA from being a chip company to owning an entire agent ecosystem. He wants all those OpenClaw builders adding value that flows through NemoClaw into paid deals. Chips to software to ecosystem. That's the dance. And look, if you're an OpenClaw contributor, and that makes you a little uncomfortable, I get it. That's just how corporate works. Linux feeds Red Hat, Kubernetes feeds every cloud's managed service. Same pattern, different decade. Open source builds the base. A company wraps it for business. But the key part isn't the business play, it's what Jensen assumes about developers. He's betting on you. He's saying you don't need a consultant to hold your hand. You need good tools and good engineering principles. And that assumption leads somewhere really interesting. And that idea, trusting engineering fundamentals, leads me to something I keep coming back to. Rob Pike's 5 rules of programming. Pike helped create both Unix and Go. He's one of the most respected names in computing. His 5 rules get taught in CS classes all over. Senior devs pass them down to juniors. They're like gospel if you write code for a living. And here's the thing, every one of them still works for building agent systems right now. I'm going through all 5 because we don't talk about them enough. Rule 1. your code will be slow in places you never expected. The real bottlenecks always hide where you're not looking, so don't slap in a fix until you've proven where the slow part is. This is exactly the problem teams run into with agents. They guess at what's slow, they swap models, they rewrite prompts, they add caching layers, all because they think they know the problem. But they haven't measured a thing. They're just guessing. Guessing costs time and money. And the worst part? The real slow spot was somewhere else the whole time. That rule didn't go out of style just because we're building with LLMs now. Rule 2. Measure first. Don't touch a thing until the numbers tell you what's slow, and only fix the part that's way worse than the rest. How many people see one bad LLM reply and want to tear the whole thing down? Baseline it first. Build a test set so you know what good looks like. Measure before you make big moves. You can't fix what you haven't measured. That rule worked for databases 20 years ago. It works for agents now, nothing changed. The tools are new, but the lesson is the same. Rule 3, don't get fancy. Fancy methods are slow when your numbers are small, and your numbers are usually small. For agent systems, simple scales well. Honestly, I'd go further, simple scales, better than complex. We used to need fancy tricks for edge cases at big scale, but now we hand a lot of that messy stuff to LLMs. The model does the hard thinking, so we need steady, simple systems under them more than ever. The plumbing should be boring and rock solid. Rule 4. Fancy methods have more bugs than simple ones. This is Rule 3's twin, but it's about bugs, not speed. And let me tell you, debugging complex agent systems is brutal. Is it the prompt? Is it the context? A bad tool call? A race between two agents? The simpler you keep it, the faster you find the answer. Simple isn't just nice. It's how you survive when code runs itself in prod. Rule 5, and this is the big one. Data dominates. Pick the right data structures, set things up well, and the rest becomes obvious. Write dumb code. Build smart data. That's the whole game. If your data is clean and your objects are well shaped, the code almost writes itself. That's the short version. And honestly, that hits even harder now that we're building with AI. Data work is the key to building good agent systems. Not fancy prompts, not messy pipelines, not some consultant's secret formula. Data. Get your data structures right and the rest follows. And the thing is, none of this is new. These rules are decades old. Every hype cycle, cloud, mobile, now AI, we forget the basics. We think everything is brand new. And we forget that keeping things simple and letting data lead has always been the move. Every time. This is exactly what Jensen is arguing for with NemoClaw, a simple set of building blocks for an open source agent world. And I think NVIDIA's engineers get this better than most right now, because when you work that close to the metal tuning GPUs, working near the core, you build a culture that demands getting the basics right. You need strong basics when you're trying to squeeze speed out of chips. And you can see that in how they built NemoClaw. So those rules sound great in theory, but do they actually hold up in 2026 production? Factory.ai decided to find out. They built an agent readiness framework with 8 pillars: style and format checks, build systems, testing, docs, dev setup, code quality, logging, security, and rules. Then they went out and used it to audit real code bases at real companies. And here's what they consistently find. The agent isn't what's broken. The setup around it is. That's Pike's Rule 5 in action. Data wins every single time. If you fix your data structures, your linter configs, your documented builds, your dev containers, your agents.md file agent behavior, just falls into place. Fix the setup, agents work better. That frees time to make the setup even better, and the loop keeps going. Better setup, better agents, more time, better setup again. That's the growth loop. Let me walk you through 3 hard problems that come up when you run agents for real. These are real 2026 problems, but they all go back to rules we've known forever. Problem 1, and this one deserves the most attention: context compression. When agents run for hours or days, they eat through their memory. Even huge context windows fill up, and every way to shrink them loses something. It always drops something. It always drops something. The question is, what gets lost and does it break the agent's next move? Factory tested 3 approaches head-to-head. Their own method step-by-step summaries keeps a neat running list split into what the session wants, what files changed, what got decided, and what's next. When it needs to shrink, only the new part gets summed up and added to the old notes. The structure keeps things safe. You build on what came before instead of starting over. OpenAI's approach squeezes things down tight, but it's a black box. You can't check what got kept. And Anthropic's version rebuilds the whole thing from scratch each time, so each round is like a game of telephone. Details slip away bit by bit. Factory's step-by-step way scored best, but all 3 lose track of which files changed over long runs. The fix? Think in milestones. Set up your work so agents can finish a piece, pass the baton, and start fresh. Use handoffs where a new agent picks up where the last one left off. That's how you get multi-week agent runs without stuffing the window. See the pattern? It's data all the way down. Problem 2, measurement, discipline, and keeping it simple. These all reinforce each other. Making your code agent ready starts with measuring. Get a baseline. Build a test set. Know what good looks like before you start changing things. If you're an engineer wondering how to contribute to the AI push at your company, honestly, just start measuring. It's not flashy, but it matters because we're giving agents real power over live systems now. And right alongside measuring strict linting, agents are basically lazy developers. Without strict rules, your code drifts into a mess at machine speed. Factory runs tight lint rules that keep agent code locked down. Measuring tells you where you are. Linting stops the slide. Put them together and they compound. Small wins stack up fast. Same principle applies to multi-agent coordination. The field is lining up around a planner-executor setup. 1 agent plans, 1 runs. Clean split. Pike said it don't get fancy until you've proven simple won't do. Don't spin up a mesh of agents when 2 with clear jobs do it fine. Start simple. Measure. Let the data tell you when you need more. Problem 3, and this is the hardest one, writing clear specs. Teams have a hard time writing clear specs up front. It takes serious work. You have to think clearly. Write it down, stay sharp, no shortcuts. And you've got to sort your info into clean layers so agents can find what they need fast instead of dumping it all into one huge prompt and crossing your fingers. We have to step up if we want agents to do good work. And I know that's the opposite of what you've been sold. The sales pitch says you kick back with your coffee and the AI does it all. That's not how it works. That's never been how good building works. It shouldn't shock us that AI is the same way. So why does all this hype and complexity keep getting sold to us? Honestly, because the chaos is worth a lot of money. Consultants show up, wave a study around, show some fancy agent diagram, and bill you for months. The scarier it looks, the more you think you need them. But here's the thing. The hard part isn't drawing fancy charts. It's getting in the code, building with the team, measuring, doing it again, and too many consultants would rather stay clean. They show up, drop a shiny deck, bill for the strategy, and bounce to the next gig. That's not how real change happens. If you want to help people figure out how their jobs are changing, and they are changing, a slide deck won't cut it. You have to start with what people know, and then show how it maps to right now. And here's what makes this moment different from past hype cycles. And that's the real takeaway here. When NVIDIA launches NemoClaw, they're not just shipping a product. They're making a statement developers are capable. Good practices that worked for decades still work. Data still wins. Simple still scales. You don't need a consultant for lessons Pike wrote down years ago. And this isn't just for senior devs. There's a new wave happening. Coding under the desk is real. It's 2026, and people all across companies, not just devs, are building with these tools. PMs, support staff, sales. Shopify was shocked by how many non-dev staff wanted coding tools right away. And if we want that energy to turn into real software, people need at least a basic grip on good building habits. LLMs are a teaching moment. They're pulling more people into building software than anything since the web. And the ideas those new builders need aren't some brand new AI thing. They're the same fundamentals that have guided good engineering for decades. So here's where I land. Next time someone tries to sell you a big agent setup with 14 layers and a mesh, ask which of Pike's 5 rules they follow. Ask where they measured before they tuned. Ask why simple won't work. The companies that win won't have the fanciest tools. They'll be the ones that kept it simple, measured it all, and let the data lead. If that lands with you, drop a like so more people see this. And go look up NemoClaw because the tools to build this stuff are open source and free. They're right there waiting for you.